Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 208. Implement Trie, also known as Prefix Tree. In this video, we are going to share two implementations of this data structure. First, let's quickly go over the main problem statement, and then we do the coding, and in between we explain the code. A trie or prefix tree is a tree data structure used to effectively store and retrieve keys in a dataset of strings. There are various applications of this data structure, such as autocomplete and spell checker. So here we are required to write a class. In other words, we want to implement several methods, like the initialization and the insert method, and the search method, and the start method. So the requirements are following the function signatures, like here, and start with. So here is one example, right? So this actually gives you some feeling about the Trie abstract data structure. So here the constraints for this problem are the following. First, the word length and the prefix length are bounded above by 2000 and bounded below by 1. And the word and prefix consist only of lowercase English letters. So here, at most, this number of calls in total will be made to insert, search, and start with. So in order to have a trie feeling, let's look at this picture. So here we have this picture. So you can understand each as a node. So here is a root. So basically it's because we can interpret this trie as a tree, so you can understand this as a node. So but you can just abstract it as a object. This is also fun. So let's see, this is a trie. So first I'm going to insert apple. So we have A-P-P-L-E. So here apple is a word, so we're going to use some attribute or some markings to make sure. So it's ending at this is the end of a word. So this is the one. So next, so we can add app. So app. So here we mark this is also an end of word. So also we can add all. So all. So this is means a end of word. So if we search for app for word, so we are going to return true. So if we search another word, let's see R, so ARE, so this is going to give us false. And so that's basically about it for this data structure. So here, in order to make a quick implementation, so because this is actually a very routine data structure in some sense, here I'm going to give two implementations. The first one, I'm going to use a dictionary object as a trie node. So here for this dictionary, so the key of the dictionary is the lowercase English letters. And we are going to use a special character or string for the dictionary object to indicate that it's the end of a word. So in the second implementation, so basically we can use a class object. So from class trie node, so make trie node, and then I would say this is some abstraction of the first method. So our plan for this video is to first implement implementation 1 based on the item 1, and then we abstract it a little bit to write another implementation. So with that said, let's look at the code. First, let's look at the initializer. So here I'm going to use a field called node, or you can use as root. So here I'm going to initialize as a dictionary. So that's it for this initializer. So next we want to do the insert. So because this tree or prefix tree is a tree data structure, in some sense it's sort of recursive. So we can use a for loop to do the insertion. first, I'm going to get the node of the trial. So let's say node. So this is the field. You notice that this node object is a dictionary, right? And then we're going to iterate over the current word. So for character in word. Basically, we want to check if the character is in the dictionary or not. If not, we're going to add that key, right? And then make a try node for that. So here we want to use a shortcut. So here I'm going to update this node, and also I want to set default. So here I'm going to use a set default. So basically, use this character as a key. So if this character not in the node keys, then I'm going to add this character to the key and give it a default value. So it's another dictionary, so I'm going to use this. Or you can just write like this. Both are okay. Then because this right after the execution of the write side, then we reset the node. So in other words, so this line does two pieces actions. And then after this for loop, what we are going to do is to indicate that it's the end of the word. So I'm going to set default. I'm going to use this again. So I'm going to use another special string, end of word. So I'm going to set it to something, any or null or something. So let's use true. So here the specific default value is not important, as you will see. We just need to check if this key is in the word in order to check if it's in the word. So this is the insert method. So now let's look at the search. So here the search is for a word. It's different from the prefix. So the difference is small but subtle. So now let's look at this. So first I'm going to get the node. So it's self node, and then we're going to following the insertion pattern. So for character in word. So here we're going to first do a check if character not in node. Notice that node is a dictionary, right? So in this case, we're going to return false. So after the check, so we're going to update this node. To update this node to be, because node is a dictionary or a trie node, it has let's see, now after this if check, so character will be a key of the node or the character or the dictionary, so we can do this. So this is the update for the node, and then afterwards what we want to do is to return, so if end of word is in the node, so because we update up to the along the chain, right? So this is search for a word. So next we want to look at start with. So for start with, we don't need that it's a complete word. So in this case, we don't need to check this part. So let me copy this part and then put it here. And then after we do this, we just need to return true. So that's the difference of these two. That's why, you know, in the end of word, it have a special key in that node, that is EOW. So with that said, I guess that this is the version V1 of implementation. Before we move forward, let's first do a check. A word is not in defined here, so I need to not only copy but use this prefix. So now let's check again. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So this is one of the solutions. So notice that in this implementation, so we regard this dictionary object as a main data field for the trial. So in the second implementation, we are going to abstract this a little bit. So let me change this one to be V1, and then I'm going to copy all these things. So I'm going to revert this to trial, and then delete all this. We're going to write another one, but the idea are entirely the same, but we just use some abstraction. So here I'm going to use another class. So here class, let's call it try node. So here let's first define the initializer. So we're going to have two things. So first is that we can define the children, right? So the children will be a dictionary. So like here, right? Like this one, we just have one. And then we're going to add an attribute or field to each of the node. I'll call it end of word to indicate if it's an end of word. So initially we're going to set it to be false. So this is a try node. So actually you can just write as a node. Let's just use this try node to indicate that we're going to use it in the try class. So now with this class try node given, so it's actually very routine to write the implementation, just following exactly the first one. So actually it would be great practice or examination to compare the two implementations. Essentially they're the same. So here for the initialization in this class, I'm going to do this, or node or root to be a try node. So because once we call this try node, so automatically we are going to, so this self root, we're going to have two fields. One is children, one is end of word. So this is to be noticed, right? And then we're going to do the insert. So for the insert, it's actually follow the same pattern above. So first I'm going to get the node. So let's see, self root. So notice that this self root is a tree node. It's a try node. So it has two fields, children and end of word. And then we're going to iterate over the word. So for character in word. And then we're going to check if the character is in the case of the children field. If not, we're going to add it, right? So here let's check if so we can do the set and check in the same fashion. So here we can do this. We can do node equals node. So here we can call the children. So this is the dictionary, right? And then we are going to set default. So what we are going to do is to check if the character is a key of this dictionary. If not, we're going to set it as a key and give it a value. That's another try node, right? So after this, then we can update this field end of word to be true, right? Because we are inserting a word here. So this is one way of writing this part. So you can do another way. Actually, let's modify it later. So after we test it. So now let's look at the search and start with. Still they are sort of similar, but only when we do the return we need to pay some attention. So first I'm going to get a node is self root, and then we're going to iterate for character in word. Then we want to make sure if character not in node is a try node, so we can check the children, right? If not, so we're going to return false. Otherwise we're going to update the node, because now after this if check, so character will be a key of this dictionary. So we are going to do node children and character, right? Then at the end what we are going to return is node end of let's see, end of word is true, right? So this is the search. So now let me copy this again, but this time let's first do modifications. So we know this should be prefix. But at the return still we don't need to do this. We just need to check return true. So this is another way of writing the implementation. So before we make modifications or comments, let's again do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So here, in this part, when we do the insertion, so actually we can do this. So let me. So this is the shorter version. Let's see. I'm going to mark that shorter version. So, but for understanding, so let's do this. Node equals self root, and then we're going to iterate for character in word. And then what we are going to do, we're going to do check if character not in node children, right? So then the meaning of this line is like this. So we're going to set node children character. So we're going to set it to be a try node. And then next, what we are going to do is to update this node. Node equals node children character, right? Then afterwards, so we're going to set node end of word to be true. So this is actually the same thing as the part we commented out, but this one is more compact, right? So let's do a check. Yeah, it passes all the cases. So actually, personally, I feel that this set default method of dictionary is very convenient. It can enable us to write very compact code. So with that said, actually we finished the second implementation of trial. So actually trial is a very common an abstract data type. Yeah, it has a lot of different applications, notably the auto completion. So in this video, actually we shared two implementations. One is using the dictionary as the tree node object, and secondly we specify a tree node class and then do the implementation. Essentially, the two methods are the same, or entirely the same, but sometimes so slightly different versions and can help understand help our understanding. So this is actually also a good practice to write different versions or different formats of solutions or codings. So with that said, I guess that's about it for this video. If you found this information or video useful, you are welcome to share with your friends or distribute it. So thank you.